Hello and welcome. Today, we are exploring a crucial concept in chromatography called dead time. You might also hear it called the void time. Understanding dead time is essential for interpreting your chromatograms correctly. It forms the baseline for all your other measurements. So, what exactly is it, and how do we find it? Dead time, represented as Tm, is the time it takes for a compound that does not interact with the stationary phase to travel through the column. Think of it as the time required to simply pass from the injector to the detector. This measurement is vital because it helps us calculate other important parameters, like the retention factor, which tells us how much a specific analyte is retained. There are a few common ways to determine the dead time. The most direct method is to inject an unretained compound. This is a substance that has no affinity for your stationary phase. For reverse phase HPLC, a common choice is uracil. For gas chromatography, you might use methane. You simply run the standard and look at the chromatogram. The retention time of that very first peak from the unretained compound is your dead time, Tm. It's that simple. Another, though less precise, method is to use the solvent front. This is the first small disturbance you see in the baseline when the mobile phase from your injection first reaches the detector. While it can be a quick estimate, it's not as accurate as using a proper unretained marker. A third method involves calculation based on the column's physical dimensions. This gives you an estimate without running a special sample. First, you calculate the column's internal volume, also known as the dead volume, Vm. The formula is based on the volume of a cylinder, Vm equals pi times the column radius squared, times the column length. But since the column is packed with particles, you must also multiply by the column porosity, which is typically around 0.65 or 0.7 for fully porous particles. Once you have this dead volume, Vm, you can calculate the dead time, Tm, by dividing the volume by the flow rate, F. So, Tm equals Vm/F. Remember to keep your units consistent, for example, milliliters for volume and milliliters per minute for flow rate, to get a time in minutes. So to recap, you can either measure it directly with an unretained compound or estimate it by calculating the column volume and dividing by the flow rate. Knowing your dead time is a fundamental step in good chromatographic practice. I hope this breakdown was clear and helpful for your work in the lab. Thank you so much for watching. If this video helped you, please show your support by liking and subscribing to the channel. It really helps us create more educational content for you. See you next time.